We are given this question: S is equal to 1, 2, 3, 4, 5, 6. It's a set. Now we got a list of 4 questions, and I'm sure that a few of the questions are easy to solve, but some of the questions require a deeper insight into the very notion of subsets. For example, first question: how many subsets are there? You can easily find that out because of the formula. So in this case, you got 1, 2, 3, 4, 5, 6. So the solution would be total subsets that could be created as 2 to the power of 6, which is equal to 64 subsets. Please bear in mind, I'm only mentioning the word subset. So having obtained that, let us go to question number 2. How many subsets have 2, 3, 5 as a subset? Now, apart from 2, 3, 5, we got elements such as 1, 4, and 6. Now, 2, 3, 5 as a whole should be a subset. So in this case, if you are going to write all the subsets of 2, 3, 5, definitely 2, 3, 5 will be one of the subset. Now our objective is to find all such sets that can produce 2, 3, 5 as one of its subset. Now of course we got 1, 4 and 6 apart from the elements 2, 3, 5 mentioned here. Now if you were to take into the subsets that can be created using 1, 4 and 6, the solution should be 2 raised to the power of 3, which is equal to 8 such subsets that can be created which contains 2, 3, 5 as one of its subset. So this is the solution for question number 2. Of course, there need to be some level of visualization in achieving the result for such questions. Okay, now how many subsets contain at least one odd number? So the requirement is either one odd number or it can be more than one odd number. Now let me use the space here. The number of odd numbers that we have is 1, 3 and 5, and the number of even numbers that we can see is 2, 4, 6. So if you were to obtain all subsets with 2, 4, 6, then we will have 8 such subsets. 8 subsets would be created. Now to get the solution to question number 3, it would mean from 2 raised to the power of 6, I need to just remove 2 raised to the power of 3. So that means 2 raised to the power of 6 is going to be 64. From 64, I need to remove 8, which is nothing but 56 such subsets will have at least one odd number. So that is the solution to question number 3. Now question number 4. How many subsets contain exactly one even number? So we got the even numbers. Sorry, the requirement is exactly one even number. So you have 2 and you got 4 and you got 6. Now 2, 4, 6, they themselves can generate. Say for example, if I were to take the set 2, this has an even number. If I were to take a set 4, it has an even number. If I were to take a set 6, it has an even number. So we can create a even number set in this fashion, but we can also create even number sets using the odd numbers 1, 3, 5. So that means we can always create a set using 1 comma 2, using 1 comma 4, using 1 comma 6. If I were to take into the number of subsets that can be created using 1 comma 2, that is going to be 2 raised to the power of 2. In this case 2 raised to the power of 2, in this case 2 raised to the power of 2. So totally 4 plus 4 plus 4. So 12 subsets are created over here, but we cannot take in all the 12. We need to only take in those subsets which has got one even number present. So that means the major part of this 12 sets would be negated. So the solution is using 1, 3 and 5 and 2, 4 and 6. The total number of subsets that can be created which has exactly one even number is going to be 3 multiplied with 2 raised to the power of 3, which is nothing but 24 subsets. So this is the solution. You can check this out, and I would encourage you all to use the comment box to give your own deduction or to give your own understanding. Thank you, students.